Mr. Akshay Sridhar, who is the Commissioner of Mangalore City Corporation. So I would request him to start sharing his experience from Mangalore. But before he makes his presentation, let me take the opportunity to introduce him. Mr. Akshay Sridhar graduated as an electrical engineer from College of Engineering, Guindy, Anna University, Chennai, before taking a leap in the government sector by cracking the civil service exam in 2016. He belongs to the IAS of 2017 batch. He has worked as Assistant Commissioner or SDM in Bidar and has been serving in Mangalore in the current posting since August 2020. So welcome, sir, and the floor is now yours.
Very good afternoon to one and all gathered here and all those appearing virtually for this wonderful conference on dump site remediation and handling of legacy waste by Center for Science and Environment. I extend my sincere gratitude to CSE for inviting Mangalore City Corporation over here and giving me an opportunity to present Mangalore's case of handling this particular problem. So to speak about Mangalore, to give a brief introduction of what Mangalore is, especially in terms of terrain and weather, will be very, very pertinent before I move on to discuss in particular about the problem. So Mangalore has a monsoon period ranging from 5 to 7 months in a year. And again, with a very, very slopey and hilly terrain. So it's a place where the Western Ghats meets the Arabian Sea. So the city of Mangalore is basically has hills on the one side and sea on the other. So there is an absolute scarcity of land and flat land. I mean, having flat land without any undulations is only a dream for any Mangalorean. So with that, so the dump site that is at present in Mangalore, or the landfill location, which is at present in Mangalore, was selected probably some 40, 50 years ago. And over multiple years, this entire area of 25 acres was where the waste was being dumped. And at the time of the selection, only the terrain was put up in such a disadvantageous location in such a way that it was located on a small hillock. And as more and more waste kept coming, the waste kept moving inward. And one fine day in August 2019, the entire landfill collapsed, leading to submergence of 17 more acres, making the land site total area of 42 acres. And this 17 acres had 2 temples and 24 houses. So this got submerged because of the heavy rainfall in 2019. And then the problem became all the more pressing and also invited more and more attention. So, a writ petition was filed in the Honorable High Court of Karnataka in 2020, mainly seeking compensation for the victims and the displaced who were affected because of this landslide. And the matter also talked about clearing up the legacy waste, and that's when the problem was taken up seriously for the first time. So after release of money for the compensation and everything, the problem of clearing the legacy waste site and clearing it either through bioremediation or incineration or biocapping it was heavily discussed. And this problem was also accelerated because a small river stream that eventually led to Maravur Dam, which also supplied drinking water to about 20 villages, also accentuated the problem because the leachate water, the leachate runoff from every monsoon was directly joining this stream, which was eventually going and joining the river. So this problem also made people take notice of it, and we at hand had a problem of this magnitude. So we are, at that point of time, we are receiving about 200, 250 tons per day. and the total area amounting to 77 acres. And the waste estimated was about 9 lakh metric tons of waste, which actually collapsed and spread all over the area. So apart from the houses, a lot of fertile agricultural land was also lost as a part of this disaster. So some pictures of a drone picture in the first slide of how the aftermath of the landslide immediately looked, and the second and third pictures from the from the time of from 2019 and 2020 when how the houses submerged look at that point of time. Some more pictures to just explain the magnitude of what happened. So, so we are presented with this problem to handle all this legacy waste. And unfortunately, we do not have any model which we could rely upon, because wherever we looked at where legacy waste has at least been partially cleared, the challenges were far too lesser than what Mangalore was facing. So with that as the backdrop, we had to factor in all of this and we had to find a solution. One thing was to have a clean environment, and the main accelerating factor here, I have to admit, was pressure mounting from Honorable High Court and also NCT and other bodies. So a lot of Mangalore is also very, very activist and very active city politically and socially. So we had to also deal with it at the same time. So we needed a quick solution to handle this problem. So the entire terrain from the top of the landfill hill to the bottom was about 30 meters with continuous undulation, and as I just described, with a river stream just running just beneath it. And the main another problem was we did not have any spare land available inside the dump site area to set up any kind of infrastructure to, bioremediate or process it. So we had to handle this problem also. We had to find land inside this dump site only to handle this problem. And as I said, there are only 5 to 6 months which you get dry period to work in, and if you have to factor in the time that has to be taken for drying of the moisture content that gets accumulated in the waste. In practice, we will be having 3 to 4 months in hand for actually doing the biomining work. So again, we have to deploy the ideal machinery. As I said, we did not have the right precedence or any strict model to just stick on to and just follow it. And there was always the possibility of further sliding, because until last year, for the 2 years after the disaster happened, with every bit of rain, a further amount of the landfill site was actually slowly collapsing. So every time we have to literally do some circus and manage the show there. Until this year, we have had some solutions, which we will discuss. And again, RDF disposal was also a big issue which we are factoring in while calculating the costs of the dump site remediation, because the nearest cement plant was located 700 kilometers away, and in between this was the Western Ghats which you have to cross. So the transport costs were running a lot. And at one point of time, when we had to send some RDF which was stored in a point of time, we literally had to shell out 3,000 rupees per ton. So which was very, very costly, and we knew that this was not going to be sustainable at all. So again, leachate management was another issue, because more than polluting the underground water and everything, it was having the possibility of affecting the drinking water that was being supplied to people. So we decided to go with bioremediation or biomining, because given this particular circumstances, soil capping was never an option at all. We had to directly remove it off. So that remained the only option at hand. So we thought that this is the only one that is going to do it. And we also wanted to reclaim a lot of land because of it, which could be further used for the solid waste management operations in Mangalore, because the scarcity in other places. And so we worked out on it, and we thought this will be the shortest possible tenure in which this project can actually get completed. So we, while analyzing the possible cost of this project, we did a fair bit of cost benefit analysis, I must say, and we decided there could be 3 options in which we could take up this project further, or on which the DPR could be designed. We thought, one, it could be completely outsourced, or two, it could be we could have rented equipment and material handling vehicles, and MCC could execute it on its own. Or the third option, we thought we could follow a hybrid model where controlled outsourcing can be used. Again, location-specific challenges have all had to be factored in, and we also thought of setting up the machinery and infrastructure in a nearby place where land was available, but then the transport cost for the same again made it very, very unfeasible. So again, the financial feasibility for such a project, and then again sustaining it, because we knew at that point of time, maybe to convince the people and to convince the courts, we could just start doing something, but then we knew that to sustain it at that rate will be next to impossible. And of course, we also have the time constraints in because we are under severe pressure to get the land cleared. So that was a major hindrance factor. So the total quantity of material to be processed based on estimations, based on excavations and standardizations, it came to about 9 lakh metric tons. We took a rough density of 0.8. The problem with this was that we were not able to exactly assess what was the density at every point. Since the waste was sliding further, we were not able to fix one particular point or fix many particular points and assess how much density of waste will actually be there. And again, we assumed a tenure of 4 years for the project, assuming that we will get at least 5.75 months per annum. So which will be literally less than 2 working years for actually to consume all the 9 metric tons of waste. So we fixed up yearly targets, monthly targets, and we worked them out based on prevailing guidelines. And we thought the maximum that could be done for this climate, having 4 lines of machinery, will be about 4,500 tons processing per day. And even that will again amount to 2 years of time. So this was the first model that we considered. That is a complete outsourced model. That is the turnkey model. So which will be handing over to one contractor for all construction, installation, and operation of the project. And we'll have a tipping fee model where based on the amount of waste that is biomined or bioremediated, we'll have to be paying the contractor. And there is no need to consider the capital costs in such a model. But that put us at a huge amount of risk, because we also assessed that no contractor would have had the experience of working in such conditions. And we have also had experiences in Bangalore where we have had contractors holding us to ransom because they held all the controlling factors. And MCC was always left in a position to negotiate with what they can give and what can be done. So we thought the first model might not work given the fluctuations in the terrain and conditions. And then we thought to take all the equipments on rent and for MCC to operate on its own. Here again, this had its own set of plus points since we will have control over the project. But then, given the history of disputes we have had, we again voted down on this. And we also realized that, renting the equipment was actually proving out to be costly, because given a 50% idle time in a year, we thought renting the equipment and just keeping it idle actually turned out to be expensive than going ahead and buying it and making it a capital investment. So we came up with this hybrid model, where the contractor will supply the machinery to the corporation, and the asset will be transferred in the name of the corporation, and the AMC will be done by the contractor who is supplying it. He will also be responsible for running it. The advantage we thought we have in this over the first model was that we thought even if we are going to run into some dispute, or if the contractor is going to run away, or if the disputes are going to cause the project to get hampered, we thought we'll have the machinery to handle with, and we can always pull in different people, or then we can have second option where MCC can itself handle it. So we always thought we can get out of this in some way. So we went ahead with Model 3. So here we explain the modalities of how Model 3 actually works. So the segregated material and everything will be taken care by the contractor. And again, a tipping fee comes in. but that will be minus the capital asset which is transferred in the name of the corporation. So we evaluated the risks that will come into play. So we thought without the cost of plant and machinery, the tipping charges were actually running lesser. And to have it for 4 years compared to the costs in other cities which have done legacy waste processing, we thought actually buying the equipment would be much cheaper. So this we had an advantage, and also we thought we'll have high quality over control over the quality of procurement. Because having our own machinery means that this problem also could be handled if it is going to escalate beyond this 9 lakh metric tons, or it is going to go run beyond the estimated 4 years due to unforeseen issues. So so as we discussed, the rental mode was not an option at all, and MCC decided to go ahead with this. So again, while assessing how the cost could be controlled, so we made two lists: one a list of variable costs which we can control, and other non-variable costs which have to be standard. So since we have lesser working time, we thought this very pertinent for our project. So we thought whatever civil structure has to be constructed, whether it is going to be 2 years or 4 years or 6 years, it is going to be non-variable. And same way, installation of the machinery was also always going to be non-variable. And again, supply of the IT tools required, and for this also will always be non-variable. So again, 5-year AMC was to be provided. Since we decided on buying the machinery, whether the project will be completed in 6 months or it's going to take 6 years, we had the buffer of having a 5-year AMC by the contractor who was legally obligated to do it. And the only thing that was variable is provided in point 3, that is the day-to-day handling of the legacy waste, which might include the legacy waste, the RDF disposal, the inert material, and also the labor charges. So, and any other additional equipment, we gave the liberty to the contractor for him or her to actually deploy it and use it. And that was a variable cost, which the bidder could actually include in their bid. Also, we left the option of RDF disposal open. Only the machineries we control what kind of machineries had to be deployed. That is the minimum number of machineries to be deployed. But other factors in the processing, including RDF disposal, we let it open because we thought in that way we can probably realize lower costs if someone can come up with an innovative idea. So again, probably we took more safeguards again here, and we thought what if again someone delivers only the machinery by quoting a lower cost and then runs away. So we decided we'll be paying only 50% cost of the machinery after he has delivered, and we will set up 3-4 milestones, and only after the completion of the project will the contractor be able to realize the full cost of the machinery as well. Even we had IoT-based tools which are already available in the market to completely track the project. And we also had a positive incentive where if the contractor could deploy additional machinery and clear off the waste sooner than the estimated time, then that could then he could have a positive monetary incentive. So AMC was again done in detail. So again, why we are repeating the AMC or the maintenance part again and again is because we have realized that it's going to take a longer time to clear because of the lesser number of working days. So we thought for the machineries to be in ideal condition will be very necessary. So these are the abstract of the costs that went into the preparation of DPR. So out of the total cost estimation, about 19 crores actually cost only in about setting up the machinery and the civil works. Because of undulating terrain, lot of civil works had to be done, including construction of sheds, leveling the land, construction of concrete platforms. So that ate up a considerable amount of cost. And again, the operation cost was figured out based on normative values. And it came to about 73 crores in total. And we here in the process of tendering, we decided to give a little leeway. We thought even if 3% of the material can be recycled, if they can be recycled, if at all, then we thought we'll reduce it from the project cost and we'll let the contractor have all of it to recycle. And we gave enough time for the bidders participating to assess the site. And if they think that so much quantity cannot be recycled or so much quantity cannot be taken out, then they very well had the option of quoting a higher cost, saying that no recyclables could be given. So finally, the contract was awarded to one NACOF, and these were the final costs that were realized. So about 626 rupees per ton, including installation of machineries, and operating cost was quoted. And with the operating costs around 413 rupees per ton. So this cost, since we had factored in, taken in the machines and bought them, the operating costs were only 400 rupees per metric ton, which was definitely the cheapest in Karnataka. And we also, of a brief overlook of various projects across the country, thought we have realized even lower rates for given the conditions that we were actually facing. So here the contractor used this rope that we gave him to dispose RDF. So sending off RDF to cement plan was kept only as his plan B, and plan A, he has come up and said that he will be ready to innovate on pyrolysis. As Honorable Joint Secretary was saying in the morning, we maintain with reverse pitching, and then they said we have a technology where we can use pyrolysis and we will try to do it. So that risk is again entirely on the contractor. So they've started the civil works for setting up a pyrolysis plant, and they have shown demo of the same in Tamil Nadu. So we are waiting to see whether how this will work, and if it works, then it will definitely lead to a lot of cost cutting. So this is a rough sketch of the map of the legacy site. So we basically divided the landfill site into various sectors, 4 sectors, where depending upon the quantity and quality of the waste available. So the sector 3 in the map is where the waste is even fresher. And likewise, as it goes down, the waste, more and more solid waste consumed, and they will be more or less of inert nature. So again, the work has been started, and instead of civil machinery, they have started setting up polyhouse windrows so that increased work time and output can be achieved, and conveyor system has been settled. So this is the present status of the project. So since the project was awarded in April, in the last 5-6 months, because of heavy rain, we have not been able to start. We have not been able to start the biomining as such, but the preliminary works have begun in full swing. And we can also say that this is the first year since the collapse where we have not had any leachate runoff to the river stream, because leachate management, which has been made as the responsibility of the contractor, has been handled well by setting in aerators and creating leachate ponds. So some pictures from the works that are going on. Again, we have to come up with making a lot of drains to all to make the leachate lesser trouble. So these areas marked in yellow are where the plants are bound to be set up. In fact, the one in the extreme right, that is where the old capped waste was present, but that turned out to be the only suitable place for installing machinery. Was relatively flatter. So we had to excavate the old waste, and we'll have to relocate it so that the land could be used for setting up new machinery. Again, this same point. So excavation has been completed at that point where now machinery is planned to be set up. And this is for the leachate collection pond where excavation has been done and a pond has been created. So that has been working so far with a geomembrane liner and human pipes. Again, we have been spraying bioculture regularly so that waste could be compressed and waste quantity could be reduced. Some more pictures. And to be frank, the work preliminary work has started in full swing. So we'll be knowing of what we have, explored into or what we have ventured into only in another probably 6 months time when actual biomining work will actually start. But so far the works have been very, very satisfactory. And if this can be realized full time, we believe this will actually change the costing game that is so far prevalent in handling of legacy waste. Thank you.
Sridhar, any question from the participants? We can do a question answer session after all the 3 cases are presented. So, or I mean, since the first one is already done, so if there is any question from participant, we can take a couple of questions right now. All right. So I would now like to invite Mr. Pankaj Bhushan and Mr. Vivek Ojha from Agra Municipal Corporation. So, and let me quickly introduce both of them. So Mr. Pankaj Bhushan is currently working as the environmental engineer in Agra Municipal Corporation since August 2021. Prior to that, he was working in the same position with Kanpur Municipal Corporation and Lucknow Municipal Corporation. And with Mr. Bhushan, we have Mr. Vivek Ojha. Mr. Vivek Ojha has gathered more than 10 years of dynamic experience in solid waste domain through handling of research, consultancy, and execution work. After completion of Masters in Environmental Science and Technology from VHU, he has explored his subject under the roof of Environmental Science and Technology, CSIR National Environmental Engineering Research Institute. Further, Mr. Ojha has served Voyant Solution Private Limited, a Ramki group of companies for more than 2.5 years. Currently, Mr. Vivek has joined hand on capacity of SWM expert with Spark group of companies, which has been entrusted by Agra Nagar Nigam to execute processing of 9.4 lakh metric ton legacy waste, a 300 TPD compost plant, and a 15 megawatt proposed waste to energy plant. Beside of this, Mr. Ojha is also providing advisory and consultancy services to different ULB stakeholders for holistic management of legacy waste, fresh waste, and plastic waste. But before I invite Mr. Ojha to present, if I may invite Mr. Pankaj Bhushan to say a few words.
Thank you, Atinji. First of all, I would like to congratulate you all to make this program on this auspicious day. Why auspicious? Everybody knows. लेकिन सुबह से हम लोग उनको मिस कर रहे हैं. Today is the birth anniversary of डॉक्टर मोक्ष गुंडम विश्वेश्वरैया जी, और उन्हीं की याद में हम लोग मनाते हैं अभियंता दिवस. आज इस डे में मैं चाहूंगा कि हमारे जो ईश्वर जी उनके लिए ताली हो जाए. मैं अपना थोड़ा जो इंट्रोडक्शन दे रहा हूँ हिंदी में भी दे रहा हूँ, इंग्लिश में मिक्स रहेगा, क्योंकि कल हम लोगों ने हिंदी दिवस भी बनाया है और आज पूरे प्रोग्राम में हिंदी दिवस है कहीं ना कहीं. तो मातृभाषा है. मैं वर्तमान में वर्किंग एज एन एनवायरमेंटल इंजीनियर इन आगरा म्युनिसिपल कॉर्पोरेशन सिंस अगस्त 2021. हमारा जो प्रोजेक्ट है कुबेरपुर वेस्ट डंप साइट रेमिडिएशन. वी हैव ट्रीटेड more than 9.4 lakhs of metric ton legacy waste scientifically. In the morning session रचना जी से कह रही थी कि क्या क्या हमारी गाइडलाइंस होनी चाहिए, कैसे हम लोगों को असेस करना चाहिए. We did all the things. कंट्रोल सर्वे हम लोगों ने कराया. कंट्रोल सर्वे के बाद क्वांटिफिकेशन हुआ. आफ्टर क्वांटिफिकेशन वी मेड ए प्रोजेक्ट. प्रोजेक्ट जो एक हमारी स्टेट की एजेंसी है, एवरीबडी नोज, आई थिंक RCUES, रीजनल सेंटर फॉर अर्बन एंड एनवायरमेंटल स्टडीज लखनऊ, उसके द्वारा प्रोजेक्ट बना. प्रोजेक्ट सैंक्शन हुआ एंड आफ्टर गेटिंग अप्रूवल फ्रॉम द गवर्नमेंट we did the tenders और रेट भी हमारा जहां तक मैं समझता हूं इंडिया में सबसे कम होगा जिस रेट पर हम लोगों ने काम कराया है. इट्स 324 रुपीज पर मेट्रिक टन. Right now, the land is total land allocated was 42 acres, and we have reclaimed 37 acres of land. Out of these 37 acres of land, 11 acres of land is being demarcated for the waste to energy plant. It's a 15 megawatt waste to energy plant, जिसको हम 35 मेगावाट पर आगे बढ़ा रहे हैं, उसकी कैपेसिटी को इनहेंस कर रहे हैं. वो प्रपोजल में है और वर्क हैज ऑलरेडी बीन स्टार्टेड देयर. जो प्रेजेंटेशन है, मैं चाहूंगा हमारी संस्था है कंसेशनर फर्म मैसेज इस्पाक के प्रतिनिधि हमारे साथ हैं, विवेक ओझा जी. मैं उनको कहूंगा कि वो अपना प्रेजेंटेशन दें और बताएं कि हम लोगों ने कैसे इसकी शुरुआत की है, कैसे इसका लेआउट डिजाइन किया है. एक जो बेसिक जो हमारे साथ चैलेंज था, मैं चैलेंज को भी आपको शेयर कर ले रहा हूं, क्योंकि जो हमारी साइट है लीगेसी वेस्ट की, इट्स द साइट फॉर फ्रेश वेस्ट आल्सो. तो फ्रेश वेस्ट वो हमारा वहां पर आ रहा था और उसको हमको अलग करना था. तो सबसे पहले हमने जो किया है कि जो हमारी 42 एकड़ लैंड थी उसमें से कुछ वेस्ट को शिफ्ट कर हम लोगों ने फ्रेश वेस्ट के लिए इस स्थान को अवेलेबल कराया. उसके बाद हम लोगों ने काम शुरू किया, बिकॉज इट वाज ए बिग चैलेंज. राइट नाउ वी आर प्रोसेसिंग 300 TPD ऑफ वेस्ट पर डे, वेस्ट टू कंपोस्ट एट द सेम साइट. इसके अलावा एक ओल्ड SLF वहां पर बना हुआ था, पुराना SLF, जो पुराना कंसेशनर था उसने उसको भी फ्रेश वेस्ट से पूरा भर दिया था विदाउट प्रोसेसिंग द वेस्ट. उसकी बायो माइनिंग का काम भी जो हमारा राइट नाउ इट्स इन प्रोग्रेस एंड इट विल बी कंप्लीटेड बाय द एंड ऑफ दिस ईयर. ओझा जी प्लीज, मैं चाहूंगा ओझा जी आए और अपना प्रेजेंटेशन दें. थैंक यू.
Good afternoon, everyone. Myself Vivek Oza. I represent here as Spark Super Infra India Private Limited. As sir has told, this project is very least cost, but this is, I think, first and last one which we have quoted the least one. Just because of RDF, we could not quote low price because RDF is a challenges for us, and the transportation cost. It's a huge cost for transportation. So it was a strategic decision of management that we have to take this project Agra for biomining, because the byproduct like RDF is one of the resource for our proposed waste to energy. That's why we have considered it and we have quoted very low price. And right now we have successfully executed the project. So now this is our Kuberpur dumping site. It has sprawl over an area of 42 acres. It's very close to Yamuna River. So that's why it's a very, it could be a potential source of contaminations if you not treat the legacy waste, if you not treat the fresh waste, if you not treat any waste through a scientific manner. If you see the entire scenario of the study area, out of 72 acres, 42 acres of land was full of legacy mixed waste, unprocessed mixed waste. So the defined project area, project site area for our project was 42 acres. It was being used for since 2011. The total population is right now approx 20 lakhs, because as we know that the Agra is one of the tourist city, international city. So floating populations contribute a major portion. Current waste generation is 850 TPD. Per capita generation estimated about 450. And the total waste quantified was 9.4 lakh metric ton. Till date, as of today, out of 42 acres, we have reclaimed 37 acres, because in 5 acres of land there is a SLF area. So the base level, what was basically contracted through our contract, we could not achieve the base level. So we cannot say that we have reclaimed the 42 acres of land. We have reclaimed only 37 acres of land, but definitely we have executed the 9.4 lakh metric ton of legacy waste. And if you see the total 9.4 lakh, the It's maybe 15%, maybe 20%, but average was 18%. It constitute RDF 18%, inert 34%, soil enricher 22%, CND and others. CND and others means like any wooden material, if big materials is come, so we can consider it and the others. So 12%. Moisture loss and processing loss, because if you are transporting a stabilized waste from the window side to the trommel side or segregation part, then definitely there will be some loss. So we have considered it, and it's about 14%. If you see the entire area, the green one, we have cleared it. It is about 37 acres. If you see the A part is basically allocated for the waste to energy, 15 megawatt waste to energy. It's about 11.25 acres. B is basically for the CND waste plant, 150 TPD it proposed. D is the 300 TPD compost plant. E, we have, it was the total biomining area, in which we have cleared 37 acres. And there is a small portion of land in the right hand side. It's basically 5 acres of land. It is basically demarcated for the fresh waste site. You could see the pictures of the dumping site also. If you see the entire legacy waste treatment, the entire activity could be bifurcated in 3 parts. The first one is related to biomining with following the SWM rules. The second one is related to, if you process the waste, definitely the byproducts, temporary storage of byproducts is one of the activity. And the third one is whatever things you are doing, definitely it should be aligned to applicable SWM rules, CPCB guidelines, and honorable NGT guidelines. So in these 3 activities has been followed in the entire projects. With following the CPCB guidelines, the activities were broadly divided into 2 parts. One is window formation. This could be called as a bioremediation. The second one is segregation through the trommel. It is basically the biomining. If you see the bioremediations process, addition of inoculum and turning. Addition of inoculum, because we understand that the legacy waste may be when we take handover, the site was basically active. So it receives the fresh waste also. So there are a lot of organic fraction of MSW. So first we have to degrade it, and after that degradations, we have to segregate it. So we add an inoculum, we turn it, we basically do the sun dry, and after a good portion of moisture loss, we do the segregation through the trommel. We uses the 3 sizes of trommel, 125 mm, 35 mm, and 6 mm. So once we use the 3 trommels, the 4 byproducts has been released. One is greater than 125, it constitutes mainly the RDF material and large objects, CND waste material. 35 mm mainly the single-use plastics and cloths. 6 mm small aggregates and sand. The -6 mm basically we call it as a bio-earth. It contains basically the drain silt, basically the night soils. These all constitute the -6 mm. When I take this project, the entire 42 acres of land, we have done the DGPS survey. After DGPS survey, we demarcated area in different phases, because we could not start the entire work in the 42 acres, and in phase-wise manner, we have to install our plant. So that's why we have demarcated in 3 different phases, phase 1, phase 2, and phase 3. Phase 1 was basically for the 5 acres, phase 2 was 10 acres, and 27 acres was the phase 3. Then we do the physical characterizations. After physical characterizations, we do the desktop study, desktop planning. From where we should start our execution plan, and where we should install the trommel, where we should make the window, what's the area of the storage of byproducts we have decided. We consider the window directions of wind, speed of wind, area availability, and in our planning. And accordingly, we have completed our site visit with the client, and one fresh waste area, because the site is active, so definitely we should think about the fresh waste storage for the period of concession time. So we have demarcated 5 acres of separate area for the fresh waste, and we created some infrastructure development for green development. Then we do the losing of waste, excavations. And if you see the entire pictures, this is basically the flow sheet. First we lose the waste, then we prepare the window, because as per the CPCB guidelines, there are 5 different methods for the bioremediations. We had adopted window with considering the area, availability of area as well as the quantity of waste. Because if we adopt another method, so it will not meet our requirement. So after formation of window, we have added the inoculum. Then we turn the waste and we try to stabilize the waste. Whether the waste is stabilized or not, we have done the seed germination method as per with following the CPCB guidelines. And once it gets stabilized, so it will transport it to the different machinery for the trommeling or segregations. The entire process is explaining the same thing. 6 set of trommel was installed at the site. Definitely all 6 have different sizes, 20 TPH, 30 TPH, 45 TPH. There was one 20 into 2. It means the feeding is through the one system, and after feeding it, they bifurcated in 2 different sets. So that's why 20 into 2, 60 TPH. So the entire, if you see that all 6 trommels is not installed in one day. First we installed a small one, 20 TPH. Then we learned something about the site selection criteria, the need of the machinery, the need of the whatever the ancillary facilities required like electricity. Then again we have then it will help us in the installation of 30 TPS, 45 TPS and other machines. We use the 4 Pokelin for the window formations, JCB8 for feeding. Those are because when we take the site was not the plane, it was in the undulating surface. It was not the scientific site. It was not the engineered site. So if you are going to prepare the window, then definitely the space, the area should be in a plain area. So it will give you a better result, efficient result. So that's why we have hired a dozer. Tipper 3 for transportation of waste. Tractor we have used because if you see the dumping sites where the 10 lakhs of waste is accumulated, we cannot run any vehicle with the speed of 30 kilometer per hour or 40 kilometers. You have to select the vehicle basis on the topography of the site, temporary topography of the site, the quantification of waste, the area of the waste, and as well as the characteristics of the waste. So we have selected tractor also, labor 32 we have in this. So entire the waste for 9.4 lakh metric ton. Initially the height of the dumping site was 12 to 15 meter. So we have divided in different layer 1, layer 2, layer 3 in 5 meter, so that in the first layer we have prepared the window, then it will be segregated, again the second layer, the third layer. So accordingly, we have executed our work. One thing I just want to mention here, window of layer 3 was stored as a cluster. Basically, during the rainy seasons, we have to plan before the rainy. So that's why whatever the waste get stabilized, we make a cluster so that water could not percolate, and whatever the waste has been stabilized, it will not have a moisture content of more than 20%. So this is our machinery systems we have engaged, Pokelin, JCB, and the tractors. These are the how we have executed our project from the commencement of work to completion of the project. This is our trommel. If you see the trommel, first we are doing the large objects. It's being hand picked. Then 125, 35, and 6 mm. We have, if you see our first trommel, we use the vibratory screen instead of the 6 mm trommel, but it was not success. We have used the ballistic separator also, but it was not success. The O&M cost was very high, and because once your machine will choke, definitely it will consume 2 or 3 days to get resumed. So that's why our work was hampered. So most of the easy, and the second one thing, most of the economical and viable technology is trommel. We have just modified something according to the waste. We have used the air separator so that the moisture content will be reduced, and the second one thing, the plastic content will be separated. We use the air separator on the 6 mm trommel, and finally we get the 4 byproducts, 125 mm, 6 mm plus 35 mm and minus 6 mm. So if you see the entire byproducts based on the size, it's being separated. These are some photographs of before and after. This is basically the after picture is SLF. This was the site before. This was basically the in front of admin building. These all are the before and after pictures of the project sites. The most important thing is byproduct management. We have analyzed our sample of byproducts from the Sri Ram lab. Definitely we give, as Jigma person was telling that there is no any heavy metals, but we found heavy metals, cadmium, zinc, and nickel was found. And it's very obvious that if you are waste management, then you must know that cadmium is the very common heavy metals it found in all the waste samples. So in the BioEarth, when it is being utilized by the being sold by us, so we have not recommended any farmers. We are just using it. We are not adding in the food chain. We are adding in the basically the horticulture purpose for any filling materials, but we are avoiding to add in the food cultures. Geocycle, we have tie up with the Geocycle for the RDF, but definitely because the nearest plant from the Agra to cement plant is from Agra to Kaimur is the distance is about 600 kilometers. So it's very it's not economic. We have signed the agreement, but the only 40 or 50 trucks has been transported from Agra. C&D is being utilized at site. Challenges we face because when we started our project, the major challenge was the identification of suitable site because this entire site was full of legacy waste. So it was a challenge for us because we have to find the good earth for the establishment of machine. So identification of suitable site for the erection of machine, electricity connection because most of the site don't have any electricity. So we face the problem. Order and infrastructure development because once you enter in the any dumping site, order is one of the challenges. Social and material security because our we have a motor, we have some MS seat. So material security is one of the challenges. Heterogeneity of the legacy waste, spatial as well as the vertical. On the different strata, the waste was different. Spatial because the 42 acres land was full of legacy waste. So spatially it was very heterogeneous in characters. Dust control because Agra have a temperature of 45-47 degrees. So dust was one of the challenges because we have a site of 42 acres. So 42 acres when a slight wind speed could erode the soil and it could be a potential source of dust pollution. Sale of RDF and plus 6 mm to authorized vendor because we can sell to the nearby people, but it is not authorized vendor. So if you sell, definitely we have to maintain the record to whom you have sell. So if someone is taking plus 6 material from your site and they are disposing in the nearby pond or nearby river area, so it could be a problem. So that's why we always send our byproducts to the authorized vendor. Transportation cost for the supply of the byproduct to a nearby vendor because it's as if we are talking about the RDF, it's a light fraction of it. So definitely the option is not viable. Transportation option is not viable. During the rainy seasons, we have also managed our leachate. So in the leachate management plan, we have identified the topography, we have identified the potential areas, we have understand the drainage pattern of the site, and accordingly we have selected 1, 2 or 3 different sites within the 42 acres, and then we have created the small channel, we dig it, and after dig it, we add inoculum and we steer it to aerations, and finally with following the CPCB guidelines we have managed it. With considering the environmental management plan, we all know that NGT is very active in Agra, so definitely we should whenever we do any planning, we should consider the environment as a component in our planning. So movement of vehicles was in a fixed route only, idle movement was strictly prohibited. Identification of hot spots, as I told you that the area is 42 acres, the temperature is 45 degrees centigrade. So we have identified some area that this is our hot spots. We have uses the green sheet to just divert the wind speed, just divert the wind directions to minimize the air pollution. Water and sprinkling to suppress the dust. A speed limit, we have created some small barrier to within the site to for the speed limit. Covering of each vehicle to avoid littering. General EHS practices we have adopted as per our company guidelines. PPE's model, PPE has been given to all the persons employee. Movement of vehicle in a confined area, ancillary activities has been carried out in the impermeable level. We could take land from the Agra Nagar Nigam apart from the 42 acres, but we have not taken because if you for window formations of any other activities, if you take, then definitely it will be contaminated. It will get contaminated. So our area was only limited to the 42 acres. So such planning, such execution plan, such factors we have considered in our planning, and accordingly the project has been executed. Some benefits we have anticipated that it will improve in the aesthetic and quality of life. It will avoid further contamination in natural environment. It will, we have developed around 15 acres of green area, whatever the land we have reclaimed. So it will, it could be enhancement of the green lungs around the city, improvement in the quality of Yamuna, elimination of fire, health hazard and breeding of flies and rodents. Realty value within the area will be increases. It could be urban rejuvenation mark in the Agra. And because within the 72 acres, 11 waste to energy is proposed, CND waste plant is proposed, ongoing legacy waste project is ongoing, fresh waste project is ongoing. So it could be a stakeholder, it could be a tourist destination for the different SWM stakeholders. These are the some pictures. Rupa Misra madam has also visited, CPC Niri people has also visited, ma'am has also visited, and Leh people has also, different ELV people has also visited. Chief Secretary and NGT member has also visited our site. This is all about our experience.
Thank you, Vivek ji. Any quick question? Okay. Can we pass on a mic, please? I think we can hear each other. Yeah.
Yes, yes, please. Actually, our 15 megawatt waste to energy is being implemented. It's under execution. Already boundary wall and civil work has been started. So I think in upcoming 2 years we'll execute the project. So it's yeah, we have stored it.
This RDF is being restored for that project.
Okay. No, it's
not event.
Okay. So we have the third case study from Leh Municipal Committee, which is a very different ecosystem, and we are really interested to learn from them, like what has been the experience. So from Leh Municipal Committee, we have Mr. Harsh Yadav and Mr. Dorje Tundup. So Mr. Tundup is working as the municipal officer at Leh Municipal Committee, and Mr. Harsh Yadav is from PricewaterhouseCoopers India Private Limited and is working as infrastructure expert at Project Management Unit for Directorate of Urban Local Bodies, Ladakh, and has been engaged in the domain of municipal solid waste for past 4 years. He is a civil engineer and has done post-graduation in advanced construction management from National Institute of Construction Management and Research, Pune. He has experience in establishment of infrastructure facility for solid waste management plants, transfer station, biomethanation plants, and floral waste management plants, in implementation of ICT-enabled solution for integrated solid waste management in smart cities. So welcome, gentlemen. Over to you, Mr. Tundup and Harsh.
Good afternoon, everyone. On behalf of Director Urban Local Bodies, your Union Director of Ladakh, I will be giving presentation on dump site remediation and legacy waste management in UT of Leh. We'll be discussing the background first, the challenges faced in the project implementation, advantages of land reclamation, feasibility options that we have considered for the project implementation, then the project implementation itself and the way forward. Our dump site was situated at Bombgad. It was located between the mountains and it had an area of about 1,15,000 square meters. The dump site has been in use for last 20 years. Leh had established a municipal solid waste management plant back in 2020. So no fresh waste was received at this site. The total quantum of waste that were identified at the site was 1,37,000 cubic meter. This was determined by total station method. And the area under the legacy waste was 82,000 square meters. We had planned to recover this entire area. Now the challenges here with what we have faced in Leh is, at first the local topography itself is a challenge, given the harsh climatic conditions and limited working time. Plus, if someone has visited Leh, they might know that acclimatization in itself is a big challenge. Then the higher service cost, because local manpower is hardly available and transportation of manpower and machinery in itself is a quite costly affair. Now we have very limited technology options there because of this harsh weather conditions. We have temperatures down to -27 degrees Celsius in the winters. So there are very little technology options that we could ask for. Then the last challenge what we had faced was the weak institutional capacity. Since the formation of UT from the erstwhile state of Jammu and Kashmir, the ULBs did not have that technical manpower who were well versed in execution of these kinds of projects. These were the three technology options that were considered for the project implementation. The first was shifting the waste to the new sanitary landfill facility. That would have required an area of 32,400 square meters and financial implication of 19.5 crores. Since going forward with this option would have rendered the land also unusable and would also have cost us a lot more money than. So this option was discarded. The next one was biocapping. Biocapping in itself is almost like a landfill. You do not get to use the land for a couple of 10 to 15 years. And plus you have to monitor the leachate and other things in that, for which the ULBs did not have the institutional capacity. And then the last option which was explored was biomining. The area requirement was not much because it can all machineries can be installed within the dump site itself. And the financial implications what was near to 11.5 crores. So this option was opted for. Now I would like to tell the advantages of land reclamation. Firstly, as we all know that it saves the cost of land instead of buying another one. It results in recovery of land where new and potential projects can be planned itself. There's revenue generation options from the recycling of RDF and other materials. And the landfill soil can be used for other purposes and other landfill works upon testing. And it also avoids that cost related to the post-closure monitoring. The dump site was divided into multiple zones through which a waste characterization survey was conducted, which yielded the following results. The density of our legacy waste had come down to 0.43 tons per cubic meter. We did not encounter organic waste into that. These are the machinery that were deployed on the site after the project implementation had taken place. They were tractor tillers, earth movers, screening and conveyors. These are mainly your trommels and air density separators, tipper trucks, and shredders. Coming on to the project progress, till date we have recovered 20% of our site that was under the landfill and have successfully remediated around 10,540 tons of legacy waste. As for the fractions that have come out of the biomining process, recyclable fractions have been sold to authorized recyclers, nearly 1,800 tons of which, consumer fractions, 860 tons RDF, We already have RDF selling that we are doing on weekly basis to Jammu. So we did not have any problem. And as per the topography, since Leh is a very arid region, we do not encounter any moisture issues with the RDF and other solid waste as well. The non-recyclable fractions, we have a plasma incinerator at the site where they are disposed of. Inert fractions are sent to the landfill, and the soils and fines, they have been tested and are planned to be used in the upcoming construction works. These are the site photos. This is the area that was under the landfill, and after some biomining work, we have recovered around 5 sectors of it. We have divided this entire site into 47 sectors. As of now, 7 sectors have been recovered. These are some more site photos. Way forward, we have planned development on the land after recovery of it. So we have planned a solar cum waste to art park there, an affordable housing project for migrant laborers, commercial complex, and parking facilities for a nearby bus terminal. That is how we plan to use the reclaimed land. That will be all from my side. Thank you.
Thank you so much, Harsh. Is there any question for Leh Municipal Committee?
Yeah, we did not encounter any. Leh has a rich biodiversity. There, people have a very different kind of culture, so we do not encounter any kind of food waste. And this site was earlier used as the name suggests, bomb guard. It was an earlier ammunition depot for the army. So only dry waste had been dumped there for a couple of years. Yes.
Okay, thank you so much to all the panelists for presenting the cases from Mangalore, Agra and Leh. Can we have a big round of applause for them, please? Thank you. Thank you, sir. Thank you. So this brings us to the last session of the day, which is our panel discussion. Unfortunately, Dr. Rakesh Kumar is not well, so he couldn't be with us today. But may I call upon Dr. Ambika Well, Dr. Sunil Kumar and Mr. Masood Malik on the stage, please. Can we have this nameplate replaced? Oh, I'm so sorry. Yes, there's a tea break. Thank you for reminding. Yeah. So let's take a very quick tea break. I would request, I mean, we are already short of time. So if we can just be back in about 10 to 15 minutes max. Okay, thank you. Richa, चाय अंदर नहीं पूछ सकता We can bring him here. And we can bring him live on the screen.